Today we'll be talking about part 2 of the two-part series of what's new with Creo 9. And today we'll be going into some of the enhancements regarding some of the extensions that they've added with this new release of Creo 9. All right, so for our agenda today, we'll be talking about the following things in order. So we'll start off with the enhancements for FREESTYLE modeling. We'll then move on to human factors, simulation and generative design, and then finally end with additive and subtractive manufacturing. All right, starting off with FREESTYLE design. So there's been some enhancements with Creo 9 and the way it handles FREESTYLE surfacing. So now in Creo 9, we have greater control of curve definition with improved modification of curvature and acceleration control points. We can now easily sculpt organic geometry with FREESTYLE brushes and MLR performance, which is what I'll be showing in the first part of the demonstration here. And now we can also, in Creo 9, mirror shapes in FREESTYLE. So with that brief introduction, let's head over to Creo and show you some of these improvements. All right, so here I have a chair surface profile here, and we're going to check out some of the new brush improvements for modifying this geometry. So if I go over to my FREESTYLE and I edit the definition for this guy, first of all, what we can do is we can improve the resolution right from our model tree over here. So if I click on the shape, right click, I can now choose right from here the resolution level for our FREESTYLE geometry. So I'll change this to 1, and you can see that the FREESTYLE geometry resolution updates accordingly here. Now, as we start making modifications to this geometry, in the past versions of Creo, it was kind of difficult to kind of sculpt our geometry using our general FREESTYLE functions. But now we have this new brush tool. So if I go up to the top and I click on this brush tool, you can see this new brush window opening and allowing us to choose different brushes to make different modifications here. So the pull brush is on by default, and basically what this will do is it will move the mesh vertices along their normal direction, okay? And in our brush settings, we also can change the size of our brush, we can change the softness and intensity. So as I increase the size of this brush, you can see that these circles that control our modification extend and change in size. If I increase the softness, you can see that the intensity of our brush represented by the red circle there gets smaller. And of course, if I decrease the softness, you can see that the intensity increases as well. And then overall intensity for our brush tool, we can modify that as well. Basically just allowing us to intensify the brush functions that come with this application here. So we'll go ahead and maybe make this brush size a little bit smaller. And I'll first start by doing the pull brush. So all I have to do to work with this new FREESTYLE brush is just hold down my left mouse button and start dragging this across our FREESTYLE geometry, right? And you can see that this geometry is mirrored over to the other side, so I'll be working mainly on this right side of this chair for this example. But you can see as I use that pull brush, it's pulling these vertices in the normal direction to my brush. Now, if I hold down Shift, you can see that the circles that represent our brush change colors. And now instead of pulling, I'll be pushing out this material. Right, so we have that ability to switch back and forth between push and pull very easily here. All right, next one we want to talk about is the selection. Now, in the past versions of Creo, it was kind of difficult to select certain areas of our FREESTYLE geometry, but now with our selection brush tool, we can very easily select these surfaces and these portions of our FREESTYLE geometry that make up our surface. So that's an added capability there as well. We also have the attach we'll go next to the flatten brush. So for the flatten brush, I can choose one of these surfaces. Let's say, for example, I would want to choose, and we'll deselect those selections that we had before. So I go to my flatten. Let's say I wanted to choose one of these surfaces. Now if I drag my brush over these other surfaces, they'll flatten according to that surface that we selected. We also have the ability to use the attach brush. So if we had maybe another body or a feature that was created from Generative Design, for example, we could use this attach brush to attach our surfaces to that geometry. And then finally, for our other brushes here, we have the smooth brush, which basically will smoothen the mesh by averaging the vertex locations. We can use the move brush, and what this will do is it will move the vertices in a desired direction. And then finally, we have the reset brush and the erase option as well. So with all of these improvements, they really just help you improve your productivity and user experience in the FREESTYLE design, basically allowing you to more efficiently sculpt your geometry. So moving on here to some of the other things we have to talk about today. The second extension we're going to be looking at is the human factors extension. And a little bit of background on human factors and kind of why PTC has been pushing to really improve the human factors extension. So really what this extension provides is the ideal solution for enabling you to visualize, simulate, optimize, and communicate these human product interactions earlier in the design process, basically helping you to save time and reduce the product development costs. So adopting a human-centric approach to design is an increasing necessity in today's competitive market. Designers in multiple industries need to understand and optimize how their products will be manufactured, used, and maintained in order to ensure that all products meet customer requirements, are comfortable to use, and possess competitive advantage. Additionally, manufacturers are often required to verify that their products and workplaces conform to health, safety, and workplace standards. So all of these things are going to be used and helped by this human factors extension. So with that, we have first the new mannequin editor. So with this new portion of the human factors extension, we can now create custom mannequin populations where you can change and define different attributes about your mannequin. And then you can also save as this mannequin as a single embedded assembly from this mannequin editor. We also have an improvement of use of the mannequin. So we have simpler mannequin manipulation and constraint handling. We now have a 3D dragger control for forward and inverse kinematics with our mannequins. We have greater control with the reach constraint, as it will show the missing distance when a target is too far. And then we have improved visibility of our mannequin and modifying our mannequin within our model tree. And then for safety, there's this new feature called a visual field. And this visual field is basically a feature you can set up with your human factors extension. We can create multiple visibility cones that are set up as quilts in a single feature. And basically what this will do is it will give us better insight into our resulting field of view and allow us to analyze the model and confirm visibility standards. All right, so with that, we'll head back over to Creo and show you guys some of the enhancements with our human factors. So I'll go ahead and open up our motorcycle assembly here. And for the rest of the demonstrations as part of this webinar, we'll be working with this motorcycle data set. And we'll just give it a second as it loads in all of the features for this motorcycle. Okay, so this is what we're going to be working with today. And basically what we're going to do is we're going to create a custom mannequin. We're going to place him on this motorcycle. And then finally, we're going to use that new visual field tool to see what the visual field looks like through this windshield of this motorcycle. All right, so I'll start by opening up the custom mannequin that we have. And let's see here. We'll go over to custom and open this guy. All right, so now that I have my mannequin open here, head over to the top tab of mannequin to open up our human factors extension. And to start off, we'll start editing this mannequin. All right, so as you can see here, we have a new mannequin editor window. And in this, we can change different attributes like height and weight, height proportion, length and width, and things like that. And basically what we do as we change these things is it's changing the dimensions that make up our mannequin. So we can see that all of our features are regenerating as we start changing some of these dimensions. So we'll go through and change the height, the weight. We're going to change the upper body length here. As well as the arm length. And then finally the waist. And now what we can do is we can save as this mannequin and create him as a usable mannequin to assemble to our motorcycle here. And I'll just call him edited mannequin. All right, so now that we've saved him, we can go ahead and close out and we can start assembling that mannequin to our motorcycle here. So I'll start by clicking on Insert Mannequin, and we'll go browse and find that mannequin that we just created here. All right, and then we are going to go ahead and pick a posture for this guy. So we're going to have him as sitting. And then we're going to go ahead and pick on our reference for placing this guy. So in here in the folder tree, I'll go ahead and select on a predefined surface that I created. If we go ahead and show that guy, we can see that this is the surface that we'll be placing him on, and we'll have him be facing another reference datum that we have. Okay. Now we can go ahead and now that we have this mannequin in here, we can see that we have this new interface for managing our mannequin. So you can see that we have the mannequin that we just put in. We have all of the components that make up this guy, as well as the ability to create snapshots. So if I go ahead and create a snapshot for this, we now have this posture and this assembled mannequin saved as a snapshot. So we can have multiple snapshots within a single assembly here to show maybe different orientations of this guy on this motorcycle, maybe have him looking left or right or something like that. So we have increased usability with our mannequin tree to make those simple and efficient changes to our mannequin as we set up this guy. All right, so the next thing we'll do is we will apply a posture. So we'll go ahead and apply a posture to this guy. And you can see that with this posture, we still need to edit him to change his hands to the correct places, maybe his legs and things like that. So to do that, we'll start out with the reach command for his right hand here. So we can select points to correctly assemble his hand to our motorcycle. And then similarly, we can also change the position of his forearm. If we need to rotate this, we have added capability in Creo 9 where we can very easily just select on the component and rotate it if we need to as well. So next we'll go to the other side and apply a reach for his hand on this handle. And again, we'll rotate his forearm to more appropriately position it on top of our handle here. All right, so now this guy looks pretty good. We can also edit the feet using the reach feature. I'm going to skip that part for now because it's kind of repetitive. But I did want to talk about some of the abilities we have with locking certain degrees of freedom for a mannequin as well. So if we take a look at this guy's trunk and we look at his lower back and we do a right click on here, you can see that we can lock and unlock certain degrees of freedom. So right now the degrees of freedom in the X, Y, and Z directions are all locked. So if we unlock that X direction, we can now maybe tilt this guy forward and have a more a more appropriate posture on this motorcycle. All right, so that's kind of how we set up our mannequin. We showed you the ability to take snapshots, which I could take another snapshot right now. We showed you the ability to assemble him to our motorcycle here, as well as the quick ability to reorient some of the parts that make up this mannequin. Now, the next thing I want to show is the ability to create a visual field. So if we go over to our analysis tab and we click on our visual field, we can now start creating that visual field. And the first thing I have to do is select on my eye point. So if I expand my mannequin, and I'll have to search for it here. The skull, we can see the read-only feature of the left eye point here. So now this is the start point of our visual field, and we want this thing to look through our windshield here. Now from here, we can select on our obstructing objects or anything that we're not able to see through. So I'll go ahead and pick on those. And we want to pick on the two assemblies here. We want to pick on the 230-5. So it's getting rid of that obstructing object in terms of the visual view or visual field. And then we can also select on the 250 assembly. So we basically just picked on these two objects here that are obstructing objects in our visual field. All right, so now we can click OK to create that visual field here. And as this guy loads, we can see that we now have this quilt that represents what this guy sees through this windshield minus the obstructing objects. This is really helpful for maybe planning out how your design will look, right? Adding that human-centric approach to our assemblies and our models can really help give you, a better idea from the start how these things will interact with humans as they use them. All right. So we'll go ahead and go back to our presentation here and continue on. All right, next we're going to be talking about generative design and simulation. So there's been a few updates with Creo 9 in terms of our different generative design and simulation tools. And starting with Creo Simulation Live, we now in Creo 9 support multi-physics with thermal and stress loads. And we can now include gyroids and lattice geometry in fluid studies. For Creo ANSYS, we now have an automatic mid-surface geometry. We have added support for bearing loads. We can now simulate unconstrained structures, which is something we've never been able to do before inside Creo Parametric. And we have some other general usability enhancements, such as copying and pasting multiple objects, controlling the number of cores in the user interface, more control over deformed versus undeformed shapes for results, and an updated simulation query. And then moving on to flow analysis. This is what I'll be demonstrating today. We now have support for multiple CFD projects in one model. We have more robust meshing with tessellation improvements, support for lattice geometry, and one of the big things is this added capability of behavioral modeling within flow analysis. So that's what I'll be showing today, is that ability to create parameters that we can use for behavioral modeling to really speed up the design process in terms of our simulation. And then finally, we have updates for generative design, and this is also what I'll be showing today during the demonstration. We now have a ability to add a safety factor target to minimize mass to that safety factor. We have updates in the modal optimization, where we're able to maximize fundamental frequency at mass and volume targets, or minimize mass at fundamental frequency floors. We also have support for ball joint constraints, and we have a better interface for running initial simulations on starting geometry to validate our design criteria. All right, so I'll head back over to Creo here, and we'll start off with this Creo flow analysis, and then we'll transition over to our updates in generative design. All right, so we'll first start by opening the assembly that we'll be working with today for our flow analysis. And sticking with the motorcycle theme, you can see that we have our kind of front end of our motorcycle here, including the windshield and some of the other frontal features of our motorcycle. And what we're going to be doing is a flow analysis on this portion of our motorcycle. We go into our applications and we open up our flow analysis. We can now open up our project that we have preloaded in here. And you can see this is basically the setup of the flow analysis I'll be running. So we have a boundary with different pressure boundary conditions, as well as a wind velocity of 60 miles per hour coming towards the front portion of our motorcycle windshield here. So I'll go ahead and load those results that I have pre-made here. And we can check out some of the streamlines that are resulting from this, right? And with the flow analysis enhancements, we now have the ability from our legend to select different variables to look at with our flow analysis. So we can select on pressure for this example, and we can, from here, start to change very quickly and easily some of these visual tools here. So we can change our line thickness to 2. We can change our animation time. We want to see how these lines are moving in animation. We can very easily do that by changing those from our new interface in Creo 9. Then we also have the ability to, instead of seeing this kind of wireframe look at our flow analysis, we can click on this little eyeball here and show the actual body in a better view here. All right, so that's kind of the new interface for our flow analysis tool. Now, one of the big things that they've added is this ability to use behavioral modeling with Creo flow analysis. So what I will do is first, we're going to set up some variables for this guy. And the first one we're going to set up is this normal velocity component. So we'll go ahead and right click on him and say add to design study. And then we can pick on our behavioral modeling tab. We can see that our input parameter has been placed in here, and now we can set up our output parameter. And we're going to set up the output parameter to be the pressure of this body. Okay, so basically what we just did was we set up our input and output parameters based on the results of this simulation. Now we can use those to optimize our design or to change some things around, maybe investigate if we change this, right, what happens? If we change the velocity, what happens to the pressure, and inversely as well. So if we go over to our analysis tab here, we can see, like we've covered in past webinars, we have these design studies that we can run here. And the first one we're going to run is our sensitivity analysis. So we can go ahead and set this up. We'll pick our velocity as our variable, and then our parameter to plot, we can pick on that pressure that we saved as well. We'll do this in 5 steps. And we're going to vary this from 50 to 90. So basically what we're doing here is we are varying our velocity from 50 to 90 and seeing how that affects our pressure on our body or on our windshield as it stands inside of the simulation. So normally I'd hit compute here, but it does take a couple of minutes to finish up. So I've preloaded the results for us. If I can find them here. And this is what it would kick out after we click compute on the sensitivity analysis. So we can see that we're ranging our velocity from 50 to 90. And we can see that, as we may expect, the pressure increases as we increase that velocity, right? So it kind of gives us a better idea of how this will change, by how much, and things like that. Now, the next analysis that we can run is a feasibility or optimization analysis. And for this case, we'll do a feasibility analysis. And again, we can add our design constraints. So for this one specifically, we're going to set a specific pressure and see if it's feasible to achieve this pressure by changing the velocity of the wind within a certain range of velocities here. So we're going to set this at, let's see here. Bear with me as I find what the value I'm supposed to put in here. All right, so we're going to vary this to 101,500 pascals for our pressure. And then for our parameter, again, we'll pick that normal velocity, and we're going to vary it for the same range as we did our sensitivity analysis for. Now again, normally I would hit compute here, and we would have the results pop up, but it does take a few minutes. So again, we're going to check out the results that I have in a separate window here. All right, so as we hit compute, it would bring up this optimization limit convergence graph, basically telling us how many number of iterations it went through to reach a optimization or a feasibility solution. And for this specific case, it did reach a solution, so it is feasible to reach that pressure at a certain velocity. And then in Creo, it will ask you, do you want to change your velocity to meet that pressure? We would say yes, and it would automatically change that velocity to this new number of 78 miles per hour. Okay. All right, so to conclude about flow analysis, we now have an updated legend selection, a more easy to use interface, and the ability to use parameters from our flow analysis for behavioral modeling analyses. All right, so we'll go ahead and close this guy out. And now we're going to look at some of the updates in generative design. So the first thing we're going to do is open up our model and kind of show you guys what part we're going to be wanting to create this optimization for. So we'll go ahead and search for it. And the part that we'll be working on optimizing today is this structure here that holds together our motorcycle foot pedal to the frame of our motorcycle. So this is what we'll be working with, and I'll kind of walk through how to set this up, what the results look like, and some of the enhancements that we have in Creo 9 for this. Okay, so we'll go ahead and open up our setup part. So this is the kind of initial geometry that we're starting with the goal of minimizing the stress during this generative design. And before we get into the actual GDX extension, I'm going to utilize one of the new features that we talked about in part 1 of the Creo 9 improvements of this surface divide. So I'm going to divide a surface on here that we're going to use to apply the load during our GDX or our generative design. So I'll go ahead and click on Editing, Split, and Divide Surface. And we'll go ahead and select on our surface here and define our sketch. We turn on our plane display. Click on this guy. This guy. And we'll also use this axis of this pin as a reference point as well. And then we can go ahead and start to create this sketch for our divided surface. So for this example, I just have a rectangular surface that I want to divide. And we'll go ahead and add some dimensions to this guy. And click OK here. And you can see we have this new surface for division that we're going to be using for some different loads as we generate this design. All right. Now if we turn on our shading with edges, we can see that we have that divided surface here. So next I'll open up the GDX, the Generative Design extension, and we can kind of walk through how to set this up and some of the new improvements here as well. So for this specific study, we have our starting geometry, and our starting geometry is this whole geometry that we were working with before. We have our preserved geometry, which are these bodies that are highlighted in blue here, and then our excluded geometry. So we have this kind of extrusion that goes through the middle of this guy to exclude from our generative design. For our constraints, we have two cylindrical constraints within these holes on this included geometry here, as well as planar constraints on the back side. And then for our loads, we have one force that's on this pin, and we're going to go ahead and add another force here on that divided surface that we just created. So I'll go ahead and add this. We're going to add a force in the z direction of 2,790 newtons. Okay. Everything looks good there. Now, one of the new features that we have in GDX is this ability to add some more design criteria. So the new function that we're going to use today is adding one of these design goals. So we're going to add a design goal of minimizing our stress to a safety factor. Like I said, this is a brand new capability in GDX. And then also adding some design constraints. So in generative design, there's 3 different types of manufacturing processes. We have additive manufacturing, milling, and casting. And for this specific part, we're going to assume that this will be manufactured using the traditional casting method. We're going to put a parting line in here. We can select our pull direction, select a draft angle, and then a draft line as well. We'll go ahead and apply those. All right, so we get that little confirmation that our study is now fully defined. And the next step is to run our initial simulation. So it'll take a second here to load our simulation. You can see that our simulation has finished. So now we can go ahead and display these results. Okay, and for these results, there's a few different things we can do with our legend again here. We can look at the von Mises stress, and we'll change this to MPa. If we wanted to see where the high and low points of stress are, we can toggle on this little icon at the bottom left here. See that our high point of stress is here and our low point of stress is here, highlighted by these little circles in red and blue. We can also look at the displacement or the deformation of this part as it stands right now. And we can animate that deformation if we want to see exactly what it looks like as it's deformed. Now, if we take a look at the safety factor for this design, in terms of minimizing our mass, we can see that the lowest point of our safety factor is at 2.48. So with our generative design, we're going to move that down to 1.6, hopefully. So we'll see what that looks like as we load up our generative design. Now, it does take a few minutes to load up our generative design. So I'll go ahead and open up the finished model here. We'll just give it a second as it loads up. All right, so we can see that we have a solution here of our new generative geometry. Now there's a couple new things they've added for displaying these results. Let's go ahead and display our results here. And one of the new things they added was this split screen view. So we can now take our initial part here, and we'll go ahead and select an orientation for both of these guys. And we can see side by side how these things compare in terms of stress, in terms of displacement, in terms of safety factor as well. And now we can see that safety factor has decreased to something more around our goal at 1.75. And again, if we animate this deformation, it'll show the difference between both our original design and our generated design. So from here, the next step would be to actually generate this design. And if I click on this, we now have the ability to choose a resolution very similar to what we saw in the FREESTYLE options as well. So I would normally hit generate. It does take a few minutes, so we'll go ahead and skip that. But basically what it does is it creates a generated part for us to then use with FREESTYLE geometry that make up the generative design that we have. All right, so we'll head back to our presentation. And we just have one more demonstration for you today. And that has to do with some of the enhancements for additive and subtractive manufacturing. So for additive manufacturing, we now in Creo 9 have support for open quilts on stochastic lattices, enabling you for the creation of skin lattices. We also have automatic redirect of fluid flow inside of formula-based lattices. We have a new variable wall for offset formula based on lattices. And we can now mix user-defined and materialized support for structures. For high-speed machining, we have a few enhancements here as well. We have better capability of surface finish for 5-axis milling. We have an increase in tool life, avoiding shatter and faster overall machining. And then finally, we have fully associative in-process stock models now available in our model tree. And the high-speed machining is what I'll be showing in the demonstration. So keep those improvements in mind as we go through here. And then some other general machining enhancements. We have added flexibility to define the NC toolpaths. We have the ability to eliminate a limitation of using only existing CL commands in Creo NC. And we have improved cutter compensation support for profile passes in the HSM rough capability. So with that, we'll head back over to Creo and show you our final demonstration for the day, showing off some of the enhancements for high-speed machining. So first, we're going to open up our part that we'll be working with. And again, sticking with the motorcycle theme here. What we're going to be machining is this hub that basically attaches our spokes to the frame of our wheel. So I'll go ahead and open up our manufacturing model. And as I open this up, you can see that we have our hub inside of our setup for our milling process here. Now, if we take a look at our model tree, you can see that we have a couple milling operations here. The HSM multi-axis rough is something that was available in Creo 8. So we have that, as well as the new capability of the 5-axis geodesic finish. So the first thing we're going to do is we're going to look at some of the toolpaths for these guys. So I can do that by clicking on it and then clicking on Show Toolpath. We can go ahead and play that for you and showing the toolpath as we rough out our first pass for this HSM multi-axis rough command. And then similarly, we could do the same thing for our geodesic finish. We can kind of see how with this geodesic finish, we have the ability to create some really, really nice surface finishes. And as we take a look at this, if I go look into the edit definition for this guy, so like I said, this is the new command that we're allowed to do in high-speed machining. And once we set up all of our references, parameters, clearances, and so on, it's very automated. So we set up all of our options here, and Creo will basically automate the toolpath that is required to create that geometry. So it's really, really a nice feature that they've added for high-speed machining. All right, so let's take a look at some of these stock models for this guy. So if we open up the display cutting, we can now use one of our in-process stock models to more accurately show how this geodesic finish will actually remove the material from our HSM rough operation. So as we zoom in and see this geodesic finish happen, we can see some of the capability around the very nice surface finish that we're allowed to do because of this new geodesic finish. So the geodesic finish is the first improvement or new thing inside of Creo 9 for machining. And the second one is these in-process stock models. If I hit cancel here, we take a look at our footer here. We now have the ability from these two operations to create stock models that we can use in process in this manufacturing assembly that we've created for machining. So I'll go ahead and click on generate this guy. All right, so we have our associative in-process stock model open here. And really just what it does is it provides us with this stock model that we can not only visually see, but we can also use as we're kind of visualizing how this thing will be machined as we go through here. So let's say we wanted to create a stock model for our geodesic finish. We could also do that by right-clicking and clicking stock model. And we can create this from our previous stock model of this HSM rough here. And again, we could go ahead and generate this, but for the sake of time, we'll go ahead and pass on that. Basically, what we would see is the final product after our geodesic finish has been completed. Okay, so just recapping on what we covered in this portion, we now have the new 5-axis geodesic finish to really help us create these complex geometries for 5-axis milling, as well as the ability to show associative in-process stock models as we're working with these parts in Creo Parametric. All right, so that is all I have for today. So I'd really like to thank all of you for listening in.